In this video, we're required to find the current I and the voltage Vx. Now let's take an approach here that is different from the one used in the previous problem, and that approach would be to use Kirchhoff's law. Now we know that the current in this branch is I. This is the current here. So let's call the current in this branch I1. And then the current in this branch would be I1 minus I. We are well familiar with Kirchhoff's law. The current in this branch would be I1 minus I. In that case, we can write a KVL equation for this loop. And the KVL equation for the loop will look something like this. This will be positive, negative. That's assigning polarities. This would be positive, negative. So the KVL equation will look something like minus 2Vx plus I1 minus 4I plus, recall that the voltage across an inductor is L di dt, so that would be 2 di dt all equals 0. Now Vx would be equals to minus 4I, and in that case that means that we would have minus times minus plus, that would be 8I plus I1 minus 4I plus 2 di dt equals 0. Then we would have it that 4I plus I1 plus 2 di dt equals 0. We can call this our first equation. Now in the second loop, you can write another KVL equation. Here we have it that okay, let's write like this. We have it that I1 plus 4 into I1 minus I minus 2Vx equals 0. Then we know that Vx is minus 4. We can then say that I1 plus 4I1 minus 4I plus 8I equals 0. Then that gives it to us that 5I1 minus 4I, that will be plus 4I equals 0. Then that means that I1 is equals to minus 4 over 5I. And we can substitute this into equation 1. If we substitute this equation 2 into equation 1, we would have it that 4 minus 4 over 5 into I plus 2 di dt equals 0. And in that case we would have it that 2 di dt equals minus 16 over 5, minus 16 over 5 I. Divide both sides by 2, di dt is equals to minus 8 over 5I, or di dt equals minus 1.6I. To go further, we can write this equation as di over I equals minus 1.6 I. If we minus 1.6 dt, sorry, if we integrate both sides, we would have it that ln I, we have ln I on this side with limits from I naught to I of t, and on this side we would have minus 1.6 t with limits from 0 to t. And in that case, we would have it that ln I of t minus ln I naught equals minus 1.6 it. Then in that case, that would mean that ln I of t over I naught equals minus 1.6 t, right? Then we can write this as I of t over I naught equals e raised to power minus 1.6 t. Okay, if that is the case, we can then substitute I naught, which is 5 amperes. That would mean that I of t over 5 equals e raised to power minus 1.6 t. Okay, then that means that I of t equals 5 e raised to power minus 1.6 t. So that is the value of I, this current I here. So that is 5 e raised to power minus 1.6 t. And what is the value of Vx? Vx is just going to be equals to 4 multiplied by I. And that would be 4 multiplied by 5 into e raised to power minus 1.6 t. And that gives us what? That gives us 20 e raised to power minus 1.6 t. And that's how we solve this kind of question. Don't forget that there's another method of solving that. I used that in solving this question. I used that in the previous problem. Thank you for watching. Don't forget to hit the like button and subscribe. See you next time. Bye.